All right, this is our final video for this particular standard. We're still working on writing and interpreting linear and piecewise models. This is video 2.2.3. It means it's our second standard and our third video. So today we're going to be talking about parallel and perpendicular lines. And remember, we're working on writing them. So we're going to be writing equations of lines parallel and lines perpendicular to a given line. So let's start with a little bit of a review of what parallel lines are. And so if I were to have an equation of a line, how about y equals 1/2 x plus 5? I can go ahead and graph that. I'm going to graph it using the y-intercept, which is 5, and then graphing a few points because I know the slope. And there is the equation graphed as y equals 1/2 x plus 5. If I wanted a parallel line to this, and let's say I knew that this line had to go through the point, I needed to go through the point 4, 2. So I'm going to go ahead and graph the point 4, 2. Now, if I want to draw a line that is parallel to this, I know that in order for them not to intersect, okay, for them to be parallel, they must have the same slope. So I can go ahead and I can graph a few points using the slope, moving away from the point 4, 2. And I do get a line parallel. So then I might need to know exactly what is the equation of that line. Well, since I know that my slope is 1/2 and an ordered pair that it is passing through is 4, 2, then I can use that information and the point slope formula, y minus y1 equals m times x minus x1, to write the equation of this line. This will give me y minus 2 equals 1/2 times x minus 4. And I can simplify that if I choose. Y minus 2 equals 1/2 x minus 2. I can add 2 to the other side, and I get the equation of y equals 1/2, x plus 0, or just y equals 1/2 x, because this is going to go through the origin. So the definition of parallel lines are two lines with the same slope and different y-intercepts. It's important to indicate that they have to have different y-intercepts, or I could actually have two lines that fall right on top of each other, which doesn't make them parallel because they're exactly the same line. So having the different intercepts at least separates them and makes them unique lines. Let's try perpendicular. So in order to have perpendicular lines, I need to be able to create a right angle between two lines. So if I use the equation that we had before, y equals 1/2 x plus 5, go ahead and graph that again. So here's my equation, and I wanted it to be perpendicular. I would certainly want it to run in the negative direction. So I'm just going to do a random line here. So I want it to run this way. So in order for them to be perpendicular, if I start with a positive slope, my perpendicular line must have a negative slope because I want them to cross. And in order for them to cross, one is going to be positive and the other is going to have a negative slope. I also want to be able to make them flip. And so we actually talk about perpendicular being perpendicular, and perpendicular lines will have opposite reciprocal. Okay, another way of saying opposite reciprocal is having the negative reciprocal. And if you think about it, if I have a 1/2 as my slope, that means that the change in y over the change in x is 1/2. And in order for them to be perpendicular and form that right angle, I need to completely reverse that. So the perpendicular slope will have a -2, as in the change in y is 2 and the change in x, in this case, would be 1. And this would give me a perpendicular line. Now, because they're perpendicular, not parallel, they could actually have the same y-intercept. So we could graph from here, and I randomly did that, but I was able to get this equation. They could have the same y-intercept if I was not given a point in which this perpendicular line had to go through. Let's try two more examples. So we're going to write the equation of the line parallel to, and I'm going to give you some information. So our first one is going to be given f of x equals 3x plus 7, and it must go through the point -5, 1. So we're going to go ahead and write that equation. And then our second equation of parallel lines is I'm going to be giving you the equation, I want a line parallel to x equals 7 through the point -2, 6. All right, so let's start with those two. So this first one here, grab a different color and go through it with you, is I need to borrow this slope because parallel lines have the same slope, and then use this ordered pair. I don't care about the rest of it. So if I'm borrowing that slope and I'm using this ordered pair, I'm going to write it in slope-intercept form. So y minus 1 equals 3 times x plus 5. Yes, you can distribute and go ahead and find this in if you want to put it in slope-intercept form. This is perfectly acceptable. It is a parallel line that goes through that point. If you want to write it in function notation, we would have to continue to solve it. So y minus 1 equals 3x plus 15, and y equals 3x plus 16. And so my new line, which I cannot call f of x because this one is f of x, the parallel line is g of x equals 3x plus 16. And these two lines have the same slope with different y-intercepts, making them parallel. All right, this next one is a line parallel to x equals 7. And it has to go through the point -2, 6. Well, this is a vertical line. So all values on this line, or all ordered pairs, begin with a 7 comma, and then the y value there's an infinite number of choices. So if I use -2, 6, let's just graph it. Here's my 7. Here's the original line. And I want a line parallel to that has to go through -2, 6. Well, it's just going to be another vertical line because parallel lines will have the same slope, and this has an undefined slope, so must the other one. So what is this equation? Well, it went through x equals -2, so the answer is x equals -2. Let's try perpendicular. Okay, so we're going to begin with some, oops, I don't want the highlighter. Let's grab the pen, and let's start with the first. Oh, goodness. All right, one example for perpendicular. I'm going to give you an original function. Let's say we start with -2/3 x minus 6, and I want this line to be perpendicular to that one through the ordered pair 1, 5. Okay, so we're going to begin by going ahead and taking this slope, but using the opposite reciprocal, or the negative reciprocal, in order I want to change that from a negative to a positive when I write my new equation. And I'm going to use point slope form. Y minus 5 equals +3/2 x minus 1. Yes, you can distribute. Yes, you can go ahead and put this in slope-intercept form, but this is actually perfectly acceptable. In fact, when I distribute, I will end up with a fraction for a y-intercept, so this might actually be easier to just leave it here. 2. Let's go ahead and write a line perpendicular. Remember the symbol from perpendicular to y equals 6 through the ordered pair 2, -1. Okay, so since I'm using this equation and I want a line perpendicular to it, well, this has a slope of 0. And the perpendicular slope would be an undefined slope. So let's graph this. 1, 2, 3, 4, 5, 6. There is my equation of y equals 6. I want to go through the point 2, -1. and I want it to be perpendicular. Well, in order for it to be perpendicular, I must write it in the form of x equals and x equals 2 in this case. So this would be the equation of the vertical line, because vertical lines and horizontal lines are perpendicular. All right, make sure that you check out the entrance slip on Schoology and bring any questions you have with you to class.